Welcome to Maths Video Tutorials, and welcome to this tutorial in which we will take a look at functions and mappings. By definition, a mapping is a rule which links every element of set A to a specific element of set B. For example, element A corresponds to element F. Element B correspond to element G. Now, for the notation, we write it down like here. F colon A correspond to B, or A maps onto B. Now, this function here is a mapping because every element of set A corresponds to a specific element of B. This one here is not a mapping because, as you can see, E is not linked up to any element of B. So this one is not a mapping. A mapping relationship can be any one of these. Can be one element from A links up to exactly one element of B. So we call this one-to-one. Or it could be one to many. Or it could be many to one. So these two here are special. The one-to-one and the many to one, because they are functions. So these two are function. So this one is a function. This one is a function. This one is not a function. So let's do a couple of examples of mappings. We're going to take a function, let's call it y equal x squared. So if I give some values to the domains 0, 1, 2, 3, that's plenty. I'm going to square this one to get the values into the image. I give us 0. That's 1-to-1. If I do 1 squared, that will give us 1. 2 squared is 4. 3 squared is 9. So this is a 1-to-1. 1-to-1. So y is a function. Let's do another one. So next function I'm going to use is y squared equal x. I'm going to give some values 9, 16, 25, 36. If x is equal 9, this means that y must have been either plus 3, because 3 squared is equal 9. Or also it could be at the same time negative 3, because negative 3 all squared also gives you 9. Same here, could be plus 4 or negative 4. Same here, could be plus 5 or negative 5. And finally, it could be either plus 6 or negative 6. So therefore you can see this is one too many. I should have put 2 arrows here. I'm going to do them now. 1 too many. So y squared equal x is 1 too many type of mapping. 1 too many. So therefore y squared equal x is not a function. In this tutorial, we're going to have a look at the definition of domain and range. What is a domain and what is a range? Now we're going to start by mapping this function. X maps into y equal to x plus 3. We're going to use the mapping diagram. We have some values 0, 3, 5, 11. Each value from the input will correspond or will map into specific value using this expression. So 2 times 0 is 0, add 3, going to be 3. So we say 0 maps into 3. Do this one here. 2 times 3, 6 maps into 9. Basically, you just substitute the values of the input into the expression to obtain the values here. 5 times 2 is 10, add 3 is 13. 11 will map into 25. Now these values here are usually called the inputs, and these values here are called the outputs. But we also call them these values, we call them domain of the function f. And these values here are called the range of the function f. So we're going to say the set of domain, you can write it down as a set like this with a curly bracket. And you just write down the values here, 0, 3, 5, 11. For the range of the function f are these values here, 3, 9, 13, and 25. And you close your bracket. So now for the type of mapping, you can see this is clearly 1 to 1. It's 1 to 1. So it is a one-to-one mapping, so it is a function. So this is a function. So f is a function. Alright, so that is the definition of domain and range. We are doing this exercise, which asks us to state whether each mapping diagram represents a function. A mapping diagram represents a function if it is a one-to-one or many-to-one. So let's have a look at the first one here. And this one is clearly many-to-one, although the others represent one-to-one, but because of this one is this one is many-to-one, so we're going to call it many-to-one. So this one is yes. So this one here is 1 to many. Can you see there is from this value there 2 connections with 2 arrows. So this is 1 to many. So this is not a function. For number 3, the mapping is many to 1. You can see these 2 here are linked to this value here. It is a many to 1. So therefore, this one is a function. For number 4, the mapping, it is a many to 1. These 2 here link up to this one here, all right? And these 2 as well. So it is still a function. For this diagram, all of them are one-to-one. So it is a function. And the last one, this one is also a many to 1. I've got these 2 link up to this, and I got this one here as 1 to many. So although these 2 are many to 1, but because of this we're going to say it is 1 to many. So therefore it is not a function, so we say no. We can find out if a given graph represents a function or not. I'm going to show you a shortcut. It is called the vertical line test. If I draw a line, a vertical line, like so, so you can see clearly this line here crosses the graph, the straight line graph, at one point only. So it is, therefore, this is a function because it is a one-to-one. You've got one value from the domain. Remember, the domain is the values that are on the x-axis, and the range is the values on the y-axis. So you can see clearly this is 1 to 1. So this is a function. So we're going to say yes. If I do it here quickly, you can see the vertical line crosses the graph at 2 different points. So we have one value from the domain that links up to two values from the range. So this is one too many. So this is not a function. For the circle, but here, similar situation. We have 2 points of intersection. So it is one too many. It is not a function. For this one here, the reciprocal graph, if I do it here, the vertical line, it crosses it at 1 point only. If I do it here, the vertical line, it will cross the graph at 1 point only. So this is a one too many. So yes, it is a function. Similar situation here, 1 point of intersection. So therefore it is one too many. So yes, it is a function. And the quadratic we have, if I do it here, it crosses it at 1 point. If I do it anywhere in the graph, similar situation, 1-to-1 mapping. So therefore this is a function. This graph represents a function. So that's how you use graphs to identify the function. The mapping f of x is split into two different expressions, x cubed and 10x. The mapping x cubed has a domain 0 to 5. Both ends are included, the 0 and 5. The mapping 10x has a domain 5 to 10. Again, 5 is included and 10 is included. Now, you can see 5 is shared between the two mappings x cubed and 10x. So we need to examine this value 5. So we need to say at x is equal 5, what are the values or the images? So we need to plug the value 5 into this expression first. 5 cubed, which is 125. And we need to plug it into this expression because it is part of this domain. So that is 10 times 5, which is 50. So you can see this is one too many. So one value from the domain will have two images, two separate images into the range. So it is a one too many. And we know that one too many mapping is not function. So we're going to say, therefore, the mapping f of x is not a function. Let's do part B now. In part A, we saw that this value 5 was the main reason for which the mapping f of x did not qualify to be a function. So now, in order for us to make the mapping f of x a function, we need to change this domain. Alright, so we need to write it down. F of x, the first one is x cubed. Now the domain will change up to 5. So we will not include the value of 5 in the first domain, and we will keep it in the second domain. So we're going to say from 5 inclusive and up to 10. Now you can see this is clearly a 1-to-1 mapping. It is a 1-to-1 mapping. So therefore f of x is a function. And that's how we answer this question. I hope that this video tutorial was helpful. Thank you for watching and take care.